most of the time in real life, if we're ever asked to come up with a discrete sort of distribution, most of the time we're not given the probabilities. Most of the time we're just given a scenario, and it's up to us to come up with the probabilities. And what we usually have to do in real life is we have to couple some of the concepts that we've already learned with the discrete distribution. And one of those is just using the combination sort of technique that we used earlier. So let's take a look at an example where we're going to use some of the things that we learned in section 8 and apply them into section 10 items. So let's say for some reason we have a small company and there's 6 women and 5 men that work at the company, and the company decides to give away some gift cards as a bonus to the employees. But there's only 3 gift cards, all right, and the recipients are chosen at random. And no one person can win any more than 1 gift card. So that way it has to be, 3 men or 2 women and a man, etc. And so let's go through first and construct the probability distribution. And then from there, what we can do is we can go ahead and do the rest of the things that we've done before. So find the expected value and interpret it, compute the standard deviation, and then find the number of women that would be considered outliers. And whether that makes sense or not, that's a different story. All right, so first things first. We have to first of all find the probability or the different scenarios that could occur. And scenarios that could occur would be that we have 0 women that win, 1 woman that wins, 2 women that win, and 3 women that win. All right, so it's like one of those or problems, like a less than, at least or an at most, except it's just everybody. So we have to compute all the scenarios. And before we do that, we actually have to figure out the number of total ways there are to win the cards. So that would actually be, there's 11 total people, and there's 3 of them. So that's going to be 11 choose 3 is going to be the total number of ways that we can select the recipients of the gift card. So remember, to compute the combination, you type 11, you go to math, you go to probability, you go down to NCR, you hit enter, and then you type in 3. All right, and that's going to give us 165. All right, so it's not an astronomical number. All right, so now we can figure out the probabilities for each of these. So 0 women is going to be, so remember there are 6 women, we want none. There are 5 men, that means all 3 of them have to win. And then finally, we're going to divide that by 165, which is the total number of ways. Now, you might remember 6-0 is 1, because anything with a 0 is 1. And 5-3, I believe, is 10, but let's just go into the calculator and verify that. So that's going to be 5, 3, and that is indeed going to be 10 out of 165. All right, so we can leave it as 10 over 165 if we really wanted to, or the probability of 0 women winning is going to be 10 out of 165, which is going to be 0.0606 or 061. Right, so 0.061. And you might remember in the previous example that that's what was given to us. All right, so with the basketball player, so somebody actually went through and figured that out for us, but we're certainly capable of doing that ourselves. And now we're at the stage where we are going to do that for ourselves. Probability of 1 woman winning the prize. There are 6 women, 1 is going to win in this scenario. There are 5 men, that means that 2 are going to win. And we're going to divide that by 165. Now we know 6-1 is 6. Remember, anything with a 1 is just the top number. 5-2, I'm not sure of that one off the top of my head, but we'll hit second enter, and then we hit second enter again to go back, and I'm going to change that 3 to a 2. And it's going to be 10 as well. Right? And then we end up with 60 out of 165. We could just multiply that by 4, or 6, excuse me. So it should be 0.366 or something like that, but let's just throw it in our calculator. 60 out of 165 is 0.364. So a little bit of rounding in there. All right. And now we're starting to get all these probabilities. All right. 2 women. And you probably figured this out by now. 6'2", 5'1", divided by 165. Now we know 5'1" is going to be 5, so that's easy. And 6'2", we don't know off the top of our heads. I believe it's 15, but let's check. So we're going to say second enter, second enter, second enter. So we have to go back 3 this time. And I'm just going to change this to 6. So that's going to be 6'2", and that's going to be 15. All right, and then we just say 15 times 5 over 165. I'm going to have to insert this if I'm typing too fast. So 15 times 5 over 165. All right, and that's 0.455. And then finally, as you can imagine, 3 women. So that's going to be 6 women. We want all 3 to win. 5, we want no males to win, and still out of 165. And 6'3". So we're going to say 6 combination 3. So let's hit second enter a couple of times. 6 combination 3 is going to be 20. So we go back here. And we have 20 times 1, because remember, anything with a 0 on the bottom is going to be 1. And then we just divide that by 165. So let's just approximate that. So 20 out of 165. I don't know why the 6 is sticking. 0.121. All right, now let's just make sure that this makes any sense whatsoever. 121. Now, for this to make any sense, these should add up to 100% or 1, or really close to it because of rounding error. Okay, so here's our probability distribution. Okay, so the outcome, and we'll figure that out in a moment. So the outcomes are, we have 0 women win, we have 1 woman that wins, we have 2 women that wins, a woman that win, and then 3 women that win. All right, remember our probabilities. So our outcomes are the number of women that win. So 0, 1, 2, 3. And then finally, we have our probabilities. Right, and that's where we're going to go back and put these values in. So we have the 0.121, and then we have the 0.455, and then 0.364, I think it was for 1, and then 0.061. And again, for this to make any sense, these should add up to about 1. Okay, so let's see. So we're going to go in our calculator. So we have 0.061, 0.364, 0.455, and then we got the last one, 0.121. Now, if this doesn't make sense, then I'm going to have to redo the video, but it gives us almost 1. All right, and there's just probably like a little bit of round off error. If we would have kept these exactly as fractions, we would have gotten the exact value. Okay, but the sum for this is about 1, and the sum is 1.001, so we're in good shape with this. All right, so what I'll do is I'll stop the video here, and then in the last part of the video, or the last video, excuse me, now that we've gotten the probability distribution, now we can go through and figure out the rest of the items, the expected value. We can figure out the interpretation of that standard of the expected value, and then the standard deviation and the number